Okay. In slide number 6 on today's practice problems, what you want to understand is that there's not a lot of information given to you, but based on what we've been able to see in the first problem, we want to do those exact same steps every time you're working a problem and identify what is my range, what is my domain, what is the description for the range, what is the description for the domain. In this problem, it says the admission to a carnival is $7 and each ride is $3. This situation can be modeled using the function f of x equals 7 plus 3x. So 7 is that base fee that you have to pay no matter what, $7 to get in. Each ride is $3. Each ride is $3, 3x, each ride. So you have to recognize here, oh, they don't tell me, but I know that x is going to be the rides. So x is my ride, and it's my domain. And then I want to recognize, well, if f of x is function notation for my y, which is my range, I want to identify what is y. Well, if I go to a carnival and pay $7 and then I pay $3 for each individual ride, you want to recognize that this is your total cost. So f of x, they don't tell us, is your total cost. In my example, yes, they told me what each individual variable was, but here I need to be able to recognize that based on the word problem. Now we have to answer the question, Mary only has $22 to spend. Okay, so you want to recognize $22 is money. $22 is like my Y. $22 is the total cost. And this is setting a barrier for me. This is setting, okay, that's my restriction on my Y values. So if I'm looking to think about, this is my total that I can spend. Let's answer the first question. Is this discrete or continuous? Well, if I one ride, two rides, can I ride a 3.5 rides? No. So because I cannot measure this and I cannot ride or think about the values in between whole numbers, we're going to say this is discrete because you cannot half it. And here you want to recognize that we are listing our values when we come up with our reasonable domain and range. Okay, so next question. What is a reasonable domain? Well, here our domain is the x, which are the rides. So you want to think about, okay, what would make sense? Do you think I'm going to have negative values? No. So since it's talking about my rides, I want to think about and say, well, I know I can ride 0 rides. And then I can continue, but I don't know how far I can go. If I only have $22, that's when I want to say, let me work this problem out and figure out how many rides I can ride if I only have $22. Well, I know my domain is going to start at 0, but I don't know what it's going to go to list the values, to list those numbers. So I'm going to take 22 and I'm going to plug it in for my y value because I know that 22 is my cost. If I plug this in for f of x, I can work backwards and say, how many rides can I ride? So if I take the equation, f of x equals 7 plus 3x, you want to recognize, what do they give me? What do I need to plug in? They give me the total amount of money I can spend, and that's going to be your f of x. So if I plug in 22 for f of x, because that's my total cost, that's my total amount, and I work backwards to figure out how many rides I can ride, that's going to give me my boundary for my x's. So here I would subtract 7, it goes away on the right. 22 minus 7 is 15, equals 3x. From here, I would divide by 3 on both sides, and so x is equal to 5. So I want to recognize this is my boundary for my x's. This means I can only ride 1, 0, 1, 2, 3, 4, and 5 rides. Next, I'm going to answer, what is a reasonable range? Well, range is your f of x, which is my total cost. Well, my total cost, I can only spend up to $22. So I know that's going to be my boundary on the right side, or that's going to be my last number, right? But I need to figure out, if I ride 0 rides, how much will I pay? If I ride 1 ride, 2, 3, 4, 5. So I can go ahead and plug in each of those values. So if I want to plug in f of 0 equals, I'm going to put 0 for x. 7 plus 3 times 0. So 3 times 0 is 0. That leaves me with just 7. So f of 0 equals 7. So if I ride 0 rides, that's $7. If I ride 1 ride, well, I'm going to plug this in for x. 3 times 1 is 3, plus 7 is 10. And then you're going to do that, and you're going to continue on for 2, 3, 4, and if I plug in 5, well, that's my max. That's my max amount I can use. So you can understand now how this problem works and how we came up with those values and why I listed them. I hope this helps.